hello everyone. This is going to be the conclusion of the section 7.4 video series on similarity in right triangles. So as a little recap, in the first video, we looked at how to calculate the geometric mean of two numbers and how to set up geometric mean as a proportion. Then we looked at how to split apart three similar right triangles when you drop an altitude onto the hypotenuse, which looks a little something like this. Oh, there's our Microsoft Word lag as usual. So at the end of the first video, we looked at if you drop an altitude onto the hypotenuse of a right triangle, we looked at how you can get three similar triangles that are formed. All of them are right triangles. And in video number 2, we looked at three shortcuts so that you don't have to draw the triangle separately every time. So we looked at how either the altitude could be your geometric mean, the left leg of the big right triangle could be your geometric mean, or the right side of the right leg of the big giant right triangle can be your geometric mean. And we looked at the mountain man analogy that kind of shows you which pieces would lie in your extremes. So if you want to have that diagram out as we work through these examples, you can. And I'll reference the mountain man in some of these as well. So at this point, we want to be able to use the shortcuts in order to solve for missing side lengths in the triangles. So what you got to figure out with these examples is which piece of the diagram, make that a right angle, not drawn to scale, which of the three yellow pieces do we want to be our geometric mean? It's either going to be the left side, the right side, or the altitude. And it really just depends on which values are given in the problem. So if I look at the first example, what I notice is that my altitude is what's missing. I have the entire hypotenuse is 50, and I have the little shadow underneath the right leg is 40 from here to here. And if we think about our mountain man analogy, let's say that the mountain man is sitting at the base of the chairlift, right? This was the peak of the mountain up here. Chairlift's over here. He could either walk 40 units to the right back to the ski lodge, or if the entire hypotenuse is 50, that means this leftover piece is 10. So he could walk 10 units to the left, and then he would be at the first aid station. So if we're going to use our analogy here, if I set my proportion up, here's my giant moguls, my snow. That's my geometric mean in this case, is that altitude. So that's going to go in the bottom left and top right corner. And then the two distances that the mountain man can travel would be 10 units to the left, gets into the first aid station. I'll even do the little labels here for the first one, chairlift, ski lodge. Or he could go 40 units to the right from where he's currently at, and he would be at the ski lodge. So if I cross multiply, I'm going to get x times x gives me x squared. 40 times 10 gives me 400. And when I square root both sides, technically I get positive 20 and I get negative 20. However, we cannot have a negative altitude. So the only answer I would keep in this case is x equals 20. So that would be the length of the altitude dropped onto the hypotenuse. Let's look at another one. In this problem, I notice the altitude isn't labeled, and I don't care to solve for it because they didn't ask for it. What they want in this problem is they want the length of the right leg of the big giant right triangle. So I can see that I'm dropping an altitude onto the hypotenuse. There's my right angle. And it looks like our geometric mean we're going to want in this problem is going to be that right side of the mountain. So here's the mountain man, skis down the right side of the mountain, goes along those giant moguls, GM, geometric mean, and now he's at the bottom. Okay, so if I start setting my proportion up, I've identified my geometric mean as the right side of the mountain, of the triangle, that's x. Once he gets to the bottom, he could either go 9 units back to the chairlift, or he could go all the way across 9 plus 3 units, which would be 12, and that would get him over to the first aid station. So I'm taking the geometric mean of 9, which is the little shadow right underneath that leg, and the entire big giant hypotenuse all the way across. 9 plus 3 would be 12. And the rest of it's some algebra. So x times x gives me x squared. Cross multiply, 12 times 9 gives me 108. If I square root both sides, I'm going to have to break down 108, since that's not a perfect square. So let's see if 36 goes in. Hey, it does. Looks like I got lucky there. Rad 36 times rad 3. So I would get, this one would come out as 6. So this would be 6 rad 3 for x. And I would ignore the negative answer since I cannot have a negative leg. So my right leg, in this case, the right side of that mountain would be 6 rad 3 units long. Okay, look at the third example. Looks kind of like the same thing we did in number 2, except this time they actually told us how long the right side of that triangle is. So the mountain man can still ski down this side of the mountain, but this time we're actually told the geometric mean is 12. And what we're missing is we're missing that little shadow underneath the left leg. So we're not going to be solving for the geometric mean this time. We're going to be solving for one of the little missing slivers of that big giant hypotenuse. But we're going to set it up the same way. My geometric mean in this case, it's labeled as 12. I don't know the altitude and I don't know the left leg, so it wouldn't make sense to use those as my geometric mean. The only one I know is the right side. So that's going to go in the bottom left and the top right corner, just like we did in number 1 and in number 2. Those numbers always have to match in the bottom left corner and the top right corner when we're doing these right triangle problems. Okay, so here's Mountain Man at the bottom now. He could either go 8 units back to the chairlift in the middle, or he could go all the way across over to the first aid station, which is 8 units plus that additional x units. So that whole distance there would be x plus 8. So when I cross multiply this, I'm going to put parentheses around the bottom right corner since we're going to have to distribute. So I'm going to get 8 times x plus 8 equals 12 times 12 would be 144. You could either divide both sides by 8 or you could distribute. I usually like to distribute, just how I do my algebra. So I get 8x plus 64 equals 144. I'm going to subtract 64 from both sides. So I get 8x equals 80. And I would divide both sides by 8. So I get x equals 10. Okay, so that's an example where we were not solving for the geometric mean, but we still had a missing piece of the triangle that got incorporated into that proportion. Okay, let's look at this one. Looks like this time I got x's popping up in 2 spots. One spot looks like it's underneath the shadow of that right leg. And the other place it pops up is actually in that right leg itself. So if I'm looking at labeled pieces, this would probably be the side of the mountain that he's going to want to ski down this time. So there's going to be my geometric mean in this case is going to be x plus 3. So that's going to go in the bottom left and the top right. He gets to the bottom of the mountain. Now, this is where you're going to have x's involved in both. He could either go, here's the chairlift. He could either go x units back to the chairlift, so put x in the top left corner, or he could go all the way across back to the first aid station, which is x plus that 12 units that we see on the left-hand side. That goes in the bottom right corner. So this one's going to have a little more algebra than the last one. I'm still going to highlight the geometric mean in this case. That's the x plus 3. It's the right side of the mountain for this problem. Put parentheses around any part that has addition or subtraction. Cross multiply. So I'm going to get x times x plus 12 equals x plus 3 times x plus 3 if I multiply those means together. So the right side, I'm going to distribute, get x squared plus 12x. And the right-hand side, I'm either going to FOIL or I can make my 2x2 table. I'm going to choose to do first, outer, inner, last. X times x would give me x squared. Be careful with that. X times 3 would give me 3x. In the middle, I get another 3 times x, so another 3x. And then the last pieces I see are a positive 3 and a positive 3, which has a product of 9. If I notice on both sides here, let's see what happens. So I get x squared plus 12x. Let me do a better positive sign. And on the right side, I get x squared plus like terms, 3x plus 3x is 6x plus 9. And we'll notice that our x squareds go away. X squared cancels out on the left and on the right. Oh my goodness. I misread the diagram. Okay, pause. We need to go back. And I'll explain where it went wrong. I misread the picture. This distance all the way across, I misread it. This whole thing is 12 units long. Okay? Not x plus 12. From here to here is x, but the whole distance across is 12. From here to here. So when I set my proportion up, I'm still going to have the geometric mean where I initially had it when I set this up. That's going to be the right side of the mountain right here. However, when I go to the piece underneath, he could go x units back to the chairlift or 12 units all the way across, not x plus 12. Okay. Sorry about the little misread of the diagram there. So cross multiplying, I get 12x equals, and I'm still going to have x plus 3 times x plus 3. So I get 12x equals, this is what I did before, that hasn't changed, x squared plus, we had 3x, and we had 9. So I get 12x equals x squared plus 6x plus 9. And it does turn into a factoring problem because you have x squareds on the right, but you do not have x squareds on the left, which means you are going to have to get 0 on one side in order to factor. So in order to get 0 on one side, I'm going to subtract 12x from both sides. So I get 0 equals x squared minus 6x plus 9. I notice my lead coefficient is 1, so I can use my earmuff shortcut. I know this has to be x, this has to be x. I need two magic numbers. They need to multiply to the constant. That's too dark. Let's do that again. They need to multiply to the constant, which is 9. I'll do it in green. And they need to add up to that middle coefficient, which is -6. So the product has to be 9. The sum has to be -6. The only way to make that work is if we use -3 and -3. Setting each factor equal to 0, it's really the same factor for this one. If you notice, it's x minus 3 twice, so it's going to give me the same answer. You don't have to solve it twice. You can just solve it once. I'm going to get x minus 3 equals 0, and if I add 3 to both sides, I get x equals 3. So that would be my solution to that one. Not every problem you encounter is going to be quadratic where you have to FOIL or you have to factor. But a lot of times when there's multiple variables popping up in different spots in the same problem, that's a clue that you're going to have to do a little bit more algebra than some of the ones that we did at the top. Okay, let's look at a couple examples where there's multiple variables involved in the same diagram. And sometimes with these problems, if you're not sure where to start, sometimes the best way to do it is try to set up the proportion, and you'll know if you get stuck because you're going to have more than one variable in the equation, and you can't solve one equation that has more than one variable. So I'll kind of show you what I mean. If I was trying a problem like this for the first time, what I would probably go to first, and this is just me, is I notice that altitude kind of just pops out of the page at me. I look at that and I say, ooh, I want to find that height. Well, that's one of my possibilities for a geometric mean. Geometric mean can be that piece, can be that piece and the 5, or it can be the 12. Those are my 3 parts of the mountain that I can allow to be my geometric mean. So let's say I wanted to go for z first. If I try to go for z as my geometric mean, that's going to be the geometric mean of, if he's standing right underneath that altitude, he could go x units to the left or he could go y units to the right, back to either edge, chairlift and first aid station. Well, that's kind of a silly proportion right now because I have, what can I solve there? I can't get z, I can't get x, and I can't get y. There's no numbers. So you got to set up a proportion so that there's only one variable involved. So we'll come back to this. Once we can get x and y, we can go back to that at the end and get z. So at this point, it doesn't really matter if you get x or y first. Let's just go alphabetically. If I want to get x, what I notice is that is the shadow underneath the 5. And the 5 is possible for me to set as my geometric mean. It's my left side of the mountain. So I'm going to put my 5 in the bottom left and top right corner. That's where my geometric mean goes. Now, Mean Mountain Man is standing in the bottom left corner at the first aid station. He could either go x units back to the chairlift, or he could go, and I won't mess it up like I did in the last one, He could go 13 units all the way across to the ski lodge over here. Not x plus 13. They're labeling the entire piece as 13. So I get, when I cross multiply, 13x equals 25, which tells me that, let's see what we get here. Divide both sides by 13, and I get x equals 25/13. And if it comes out to a nice clean answer, we can leave it as a decimal. It does not, so you do not want to give a decimal answer. That is a decimal that goes on forever without a pattern. We would not even be able to math frac that. Actually, that's false. We just got a math frac on that, 25/13. So we'll leave it as 25/13. Okay, let's get y. This time we're going to use the right side of the mountain. So from here to here, mean mountain man goes down this way now in blue. So we're going to make it blue now. He is now down at the bottom of the ski lodge. So he went down the right side of the mountain, which they labeled as 12. So that's going to go in the bottom left and top right corner as our geometric mean, giant moguls. He could go back to the chairlift, which is y units away from the ski lodge. Or he could go all the way across 13 units back to the first aid station. So it's the geometric mean of the shadow underneath the leg and the entire hypotenuse, which is 13 units long. So if I cross multiply this one, I get 13y equals 144. Divide. I get y equals 144 over 13. And you'll see on your calculator, that's another one that has a decimal that goes on forever. So we don't want to leave a decimal answer. Let's see if it simplifies. I'm going to do math, enter. Nope, looks like 144 over 13 is as good as that fraction gets. Okay, so now we can go back to our original thought, which was to get z. Okay, so if I do that, I'm going to go back to our original proportion. Now we're looking at the black altitude that I'm labeling here. That was where we got stuck originally because we didn't know x and we didn't know y. Well, now we do. So I can actually set this proportion up now where z is my geometric mean. And it's the geometric mean of the two little pieces making up the big hypotenuse, which is x and y. We got x to be 25/13, and we got y to be 144/13. So if I cross multiply that, I'm going to get, let's see what we get. Let me erase all these little dots that Microsoft Word created here. I'm going to get z squared equals, I'm going to do this on my calculator. So I'm going to do 25/13 in parentheses times, open another set of parentheses, 144 divided by 13, close the parenthesis, which is right next to the division sign. Hit enter. And I'm going to math frac that so that I get a fraction. So I get 3,600 over 169. They don't come out super clean, but that's okay. Last thing we do, we have z squared. We want z, so I got to square root both sides. So I'm going to square root, see if it comes out to a clean answer. Second x squared is what you want to hit. So second at the top, x squared. And then what you can do is you can type in 3,600 divided by 169, or you can hit the up arrow. It'll highlight your answer. You can hit enter, and it'll pull it right down so that it puts it underneath the radical for you. Either way. And it comes out to a nice clean 60 over 13. So that's how you do a problem where there's multiple variables involved. You're going to have to set up a proportion so that you only have one variable in the proportion. And come back to the other ones later like we did here. Okay, why don't you try number 6, and then I'll do some setup and go through that one. So pause me, try number 6, see what you get, and then I will run through that example to end out. Okay, number 6. We learned in the last one that we want to set up proportions so that we only have one variable at a time. So just like in the last one, you'll notice we're going to run into problems if we start with z, because that's going to be the geometric mean of x and y. It's going to have 3 unknowns in a proportion. We don't want that. So the first thing I'm going to do, I'm going to choose to use 20 as my geometric mean. I have 3 options, right? I have 20, 21, or the altitude. So for my first round, I'm going to choose to let 20 be my geometric mean. So mean mountain man's going to go down the mountain, and he's going to be in the bottom left corner. So first thing I'm going to do is get x. So my proportion, check what you got. You should have 20 in the bottom left and top right corner, and you should have x in the top left, and the entire hypotenuse is 29 in the bottom right. Cross multiply, you get 29x equals 400. Divide by 29, get 400 over 29. And I don't think that reduces anymore. Let's see. Nope, 400 over 29 would be your answer for x. Do the same thing for y, except we're going to use the y shadow instead of the x shadow. So now I'm going to have Mountain Man go down the right side of the mountain. So I'm going to use geometric mean in blue for the second part. Say goodbye to this geometric mean Mountain Man and say hello to this geometric mean Mountain Man. So we're going to get y. Okay, he's at the ski lodge. He went down that 21 unit long set of giant moguls. He could go y units back to the chairlift or 29 units all the way across. Cross multiply, I get 29y equals 21 squared, I believe, is 441. Let's see. Yeah, 441. Divide both sides by 29. Math frac that. And I get 441 over 29. Last but not least, I'm going to come up here so you can see z. So last one I'll do up here, get z. Well, now we found x, check. We found y, so now we can go to our last setup, which would be to let the altitude be our geometric mean, which I'll do in black. So z is going to go along the bottom left and top right corner as our GM. It's the geometric mean. If he's standing at the chairlift, he could go x units to the left. X was 400 over 29. Or he could go y units to the right to the ski lodge, which was, I believe, 441 over 29. Let's see what we got. Yeah, 441 over 29. Cross multiply like I did in the last one, I get z squared equals, so we got 400 over 29. Hit enter. Multiply it by, in parentheses, 441 over 29. Hit enter, math frac it, big number, but it's going to get smaller because we got a square root. 176,400 over 841. Square root to get rid of the z squared. So I'm going to do second x squared. Again, you can type in that number again or hit the up arrow. It highlights it, hit enter, brings it inside the radical, hit enter again, and it gives you 420 over what was the denominator? 29. And that's how you solve one with more than one variable in the picture. All right, so that concludes similarity in right triangles. Math Excel is up and running for you to try some of these out. And we'll continue to practice in class. Congratulations, you just completed the ultimate brain workout. Happy mathing.